Introduction to Modeling of Simple Electrical Elements. For the electrical system, we have to start from the passive electrical elements. What are they? Resistor, inductor, and capacitor, as you see here. ERT is the voltage across to the R, and ELT is voltage across to the L or inductor, and ECT, as you see here, across to the capacitor. For the resistor, we will use always Ohm's law, as you know, and this formula represents the voltage of the R. Inductors, for the inductors, we can use this formula. ELT is equal to L times the first derivative of the current. And capacitor, we will use the integral of the current over by C. Yes, modeling of the electrical networks. Take a 10 minutes break now. For the modeling of electrical networks, we will use current law or loop method, which is the algebraic summation of the all currents entering a node is zero, as you know. Voltage law or node method, the algebraic sum of all voltage drops around a complete closed loop is zero, as you know. We'll consider RLC circuit, RLC network. Input is ET. The output can be accepted as ECT or E output T. Okay. If you do a loop here, you can write ET is equal to RIT plus ELT, it's mean L di T over dt plus ECT. This is the first equation. ECT can be, IT can be written as C dECT over dt, as you know, because the same current, because of the series elements. This is the second equation. By evaluating the equation 2 into the equation 1, ET can be RC dECT over dt, L d LC d square ECT over dt square plus ECT. This is the dynamic equation for the RLC circuit. We can divide LC component, all of this equivalent, plus RC over LC dECT over dt plus ECT over LC, it's equal to ET over LC. Some components will be removed as here, so the final equivalent can be given the second derivative with two nodes as like that, plus R over L, the first derivative of ECT, plus 1 over LC ECT is equal to 1 over LC ET. As I said before, this is the input for this circuit and this is the output. We defined as like that. And again, we can convert this equation to the prototype second order system. What is this? ECT plus 2 C omega n ECT plus omega n square ECT is equal to omega n square RT, right? Or ET. As you see here, this is the same with the before defined equations. This is the second order prototype system. This is the analogous with the other systems. Okay, let's continue now. As you see here, the equation belongs to the RLC system, can be obtained as like that, and it is the same with the second order prototype systems. Maybe we can do this example now. Consider RC circuit shown in figure 2.23. Find the differential equation of the system using the voltage law. Okay, let's do this now. Yes, as you see here, the input is the input voltage again. The output is the voltage across the capacitor again. Okay, let's do this now. This is the RC circuit, as you see here. Let's do this now. In here we have a loop again. Here we have a loop. Let's write it now. E in T is equal to ER plus EC. ER means R times IT. EC means EC because we select EC as output. Okay, so it is the same. This is the first equation for us. The second equation, how can we write another equation? In this equation, as you see here, we have to get IT according to the input or output. How can we get? IT is C times DECT over DT. This is also capacitor voltage. It is not another branch. It is a measurement of voltage, okay? Such as a multimeter or oscilloscope. So we can write equation 2 into the 1. E in T is equal to R times C times DECT over DT. Okay, and then plus ECT. The higher differential equation is given here. So we have to divide it 1 over RC of all equation as like that. E in T over RC is equal to DECT over DT. It's a notation, okay, that's all. ECT over RC. Okay. This is the standard first order prototype system, we can say. And we say this in here, RC is the time constant of the system. Okay, time constant of the system. It's so important for the this term is so important for the control theory. We will see later, but now we know this. So we can write also represented as tau, as you see. We can write the same equation as like that. DECT over DT plus 1 over tau ECT. Okay. This is a prototype of first order system. Okay, that's all. The same equation can be seen in 2.84, and this is the standard first order prototype of the system. In here we have another examples. You can do these examples in your homes. Yes, introduction to modeling of thermal and fluid system. We don't responsible from this part, and from the fluid part we don't responsible.